Greetings everyone. Today we're going to explore writing square and cubed root functions. To help us today, let's quickly review what we already know about transformations. A negative in front of the function is a reflection in the x-axis. The value in front of the function shows me a vertical stretch or compression. The value being added or subtracted within the function, whether it be a square root, a squared, that's going to be your horizontal shift. Remember that this is the opposite. So if it says -1, that means right one. And lastly, a number that's being added or subtracted outside of the function, whether it be at the end or at the beginning, is still a vertical shift up and down. And there's nothing special about the signs. So today, understanding those four pieces of information are going to help us write our function. We do have a note sheet for this, just with two little graphs so you don't have to worry about sketching them. Let's start off with this one. Now to begin, I like to start with what I know. F of x equals, I know that this is a squared root function and it's going to have an x in it. Let's start off with the basics. The starting point is moved left 6, so we write that as a +6 in the function for my horizontal shift. My vertical shift is up 1, so we want to add 1 on the outside of the function. It's a positive function because it's going up and to the right. But the piece that I don't know is the a value. I could make some assumptions, but I want to show a little bit of work on finding that a value. To find that a value, we need to use a different point, not the starting point. We need to use a different point. And there's a couple of options. Like I see, I could probably use 0, 6 as well. But if you're given a dot, I would recommend using that one. So in my function, I'm going to plug in this x and y value. So 5 and -2 are going to get plugged in for my x and my y. Oops, too far over there. Now we want to solve using PEMDAS, meaning we want to undo any addition or subtraction first. If I take care of the radicand, that would be square root of 4. Well, square root of 4 is 2, and the a are next to each other, so it's multiplying. So if I divide, I've got an a value of 2. So let's write our final function, right? Finding the a value is just part of your work. My final function, f of x equals 2 squared root of x plus 6 with a +1 on the outside. Let's take a look at this one. I can see that this is going to be a cubed root function, so I'm going to get it set up here. We want to look for that center point. The center point represents our horizontal and vertical shifts. So right here would be that center point. So we went right 1, we're going to write -1 in the function. My vertical shift is a +2. It's positive because it's increasing over time, and what I need to work on is finding the a value. Now, when you use a different point to find your a value, it cannot be the center point. You can't reuse the numbers you already used. So I have to pick something else. So I see that I'm crossing at 0, 0. If you have something that simple and easy, definitely use that. So instead of x and y, I'm going to plug in 0, 0. Let's fill in the rest here. Solving using PEMDAS, I'm going to kick that 2 over to the left first. 0 minus 1 is -1. The cubed root of -1 is -1. We're going to divide both sides, and conveniently I have an a value of 2 again. Let's write our final function. Remember that a value can be a fraction. That a value can be positive or negative. If you already placed the negative in because you notice the reflection, then that'll work itself out. So we have a factor of 2 and x minus 1 with a +2 outside. Again, key point, this is going to be important come your practice and your homework. You cannot reuse the center point. You have to find a different point to use to find your A value. And that's it, pretty quick. This is an easier lesson, so make sure you check out Google Classroom to see what the task is today. If you need help with those transformations, see our other videos about graphing. Let me know if you have any questions, and until next time, have a good one.